Okay, so last time I asked you to practice 2.6 problem, 2.6, 2.7, 2.8 and 2.9. I do hope you have practiced these problems. So why I ask you to practice these problems is that most of the time in the exam, one or two problems from the text is asked, and from this unit 2 structure of atom, one numerical problem is expected to come. Okay, so it's high chance, okay, that one questions related to numerical problems will come in exam. Okay, probably for 3 marks. So that's why I ask all of you to practice. Okay, so when you practice, okay, you get better idea of the problems. Okay, so the more you practice, the more helpful it will be, okay, for exam. So let us discuss, okay, some few questions. Find energy of each of the photons, okay, which correspond to light of frequency 3 into 10 to the power 15 hertz, have wavelength of 0.50 angstrom. So the question is asking us to find the energy, okay, energy of the photons. Okay, energy of the photons, the first one, okay, which correspond to frequency of 3 into 10 into power 15, okay, hertz. Second is of wavelength 0.50 angstrom. Given, okay, frequency is 3 into 10 to the power 15 hertz. So for first one, okay, energy, so from Planck constant we get the relations, okay, of energy as h nu. Okay, so Planck constant h value is 6.626 into 10 to the power minus 34 joule second into this already given, okay, nu or frequency. So frequency can be written as second inverse, okay, frequency is equal to second inverse, okay, or we can say nu, okay, or frequency unit is given as can be given as second inverse. So if you multiply, before multiplying you can cancel this second, okay, and then joule remains. So if you multiply these two, what you will get is 19.878, okay, and then 34 minus 15 will give minus 19, okay, joule. Or we can add, okay, 1 0 here, okay, we can take out, okay, 1 0 and then make it 1 point, okay, 1.98. So therefore energy is equal to 1.9878 minus 18 joule. So in most of the numerical problems you will see the value, okay, here is single digit and then follows by point or decimal. Number 2, okay, wavelength. So given wavelength lambda as 0.50 Armstrong. 0.50 Armstrong when converted to meter, 0.50 into 10 to the power minus 10 meter. So last time I asked you to write down about the value, okay, how to convert nanometer to meter or Armstrong to meter, okay, or picometer to meter. So remember those values. Now energy, you have to find the energy E, okay, since lambda is here, okay, so we will use this formula as C by lambda. Value of H we know 6.626 into 3 into 10 to the power minus 34 joule second into C, speed of light, okay, 3 into 10 to the power 8 meter per second. Lambda given 0.50 into 10 to the minus 10 to the power minus 10 meter. Meter cancel, second cancel. Six 6.626 into 10 to the power minus 34 joule into 3 into 10 to the power 8, and if you bring this up here it will become minus, will change to positive, okay, plus 50. So if you divide this, okay, you will get 39.756 into 10 to the power minus 16. So like here, okay, you can minus this power like this, okay, you can minus. Likewise, if you minus this, you will get 10 to the power minus 16. Therefore E will be, if we take out one more, okay, 0, 3.9756 minus 15 joule. So for first one also, okay, after one digit we are taking one decimal, okay, and for the second one also, okay. The next questions: what is the number of photons of light with a wavelength of 400 picometer that provide 1 joule of energy? So we have to find the number of photons, okay, of light. Given lambda or wavelength 4000 picometer. So if you convert this 1000 into 10 to the power 12 meter, okay, if you convert this to meter it will be 10 to the power minus 12. Energy given 1 joule. So in these questions, okay, first we will find the energy of one photon. So now energy E C by lambda, so 6.626 into 10 to the power minus 34 joule second. Speed of light 3 into 10 to the power 8 meter per second. lambda value here, 12 meter. So what you can do is you can cancel this second, meter. So if you multiply this and this, okay, it will give 19.878, okay, minus 34 10 to the power 8. Then if you bring this up, it will become plus. So you can cancel the 0, okay. So 8 minus 3 will give 5. So if you divide these two, it will give you 4.9695 10 to the power minus 17 Joule. So now for calculation of number of photons, okay, number of photons, and so Joule by this, okay, 4.9695 10 to the power minus Joule. This will give the number of photons, okay. So number of photons, okay, will be like total energy divided by energy of one photon. So the total energy is given here, 1 Joule, and energy of one photon here, okay, we already got this, so we'll divide. So Joule you can cancel. Okay, if you divide these two, what you will get is 2.0122 into 10 to the power 16, okay, photons. So in this case also, okay, if you bring this up, it will become plus 17, and okay, by converting, okay, you will get this 2.0122 into 10 to the power 60. Okay, so after one digit decimal come, and then you get the answer. The next question: a photon of wavelength 4 into 10 to the power minus 7 meter strikes on a metal surface. The work functions of the metal being 2.13 electron volt. Calculate the energy of the photon in electron volt, the kinetic energy of the emissions, the velocity of the photoelectron. The one photoelectron already given here is equal to 1.6020 into 10 to the power minus 19 Joule. Solution: given lambda is equal to, wavelength is equal to 4 into 10 to the power minus 7 meter. Minimum energy, okay, to eject an electron, okay, minimum energy required to eject electron as V naught, or we call it as work function, okay, minimum energy required to eject an electron. So this is equal to work function. So work function is given 2.13 electron volt. Work function, okay, 2.13 electron volt. So the first question is asking, okay, the energy of the photon. So we are going to calculate the energy. lambda so energy hc value we got, lambda also we got, and after calculations what you will get is 4.969 into 10 to the power minus 19. So 1 electron volt, we know 1 electron volt is equal to 1.6020 into 10 to the power minus 19 joule. Okay, so we have to find this in terms of electron volt, the energy in terms of electron volt. So energy in electron volt, so what we are going to do is we will take this value 4.969 10 to the power minus 19 divided by this value, so after multiplication, after multiplication and dividing, what you will get is 3.10 electron volt. To the kinetic energy of the emission, kinetic energy of the emission. So the kinetic energy of the emission, or we can say kinetic energy of the ejected electron. So kinetic energy will be equal to h nu by h nu naught, the minimum energy minus by the energy, the minimum energy required to eject an electron, minus the energy of the photon or electron. So h this energy of the photon we got 3.10 electron volt. Before going to this value, from this question we got this one also, the value of work function 0.13 electron volt. Now what we are going to do is see the kinetic energy mv square, so 3.10 minus 2.13, this will give 0.97 electron volt. So this is the kinetic energy, this minus this will give the kinetic energy of the ejected electron. So we have got the kinetic energy of the ejected electron as 0.97 electron volt. The third questions, the velocity of the photoelectron. So we have to find the velocity, this one, v square of the photoelectron, v kinetic energy 1/2 m v square is equal to 0.97 electron volt. So we are going to convert this electron volt to joule again. 0.97 into 1.602 into 10 to the power minus 19 joule. So 1 electron volt or 1 joule, is equal to this one. 1 electron volt is equal to this value. So we are going to convert this electron volt to joule. So we are using this value here, again, okay, to convert it to joule. So this velocity, okay, velocity cannot be expressed in electron volt, so we're going to change into meter second per second, okay. The unit of velocity is meter per second, so we are going to convert again, okay. So while calculations, the unit becomes important, okay. So at the end of the answer you need to mention, okay, give the unit also, so we know that the unit of velocity will be meter per second. So we are going to change, okay, this electron volt to joule and then convert it to meter per second. Okay, again one more thing, mass of electron, okay, or one electron, 9.11 into 10 to the power minus 31 kg. So this m, okay, is the mass of electron or mass of one electron, okay. So we're going to write this value also to find the velocity. Now if you bring v square here, okay, what remain will be this 0.97, 1.02 minus 19 joule, okay. Before adding joule we can add this one, and then 2 comes here, this value will come down here. So if you bring this up, okay, it will become plus 31, okay. If you bring this up and then if you multiply the above, okay, above values, okay, you will get certain value, and if you divide by 9 by the above values, it will give 0.34112, okay. So this and this cancel, okay. So 1 joule is equal to 1000 kilojoule, or 1 joule is equal to kilojoule, okay. 1 joule is equal to 0.001 kilojoule, okay, or we can say 1000, okay. So we got this value, but since this is v square, okay, we have to convert it to v. And velocity, the unit is meter per second, okay. So in order to convert this to this one, we have to add square also, okay. In order to convert this to this value, we are adding 2 here. Now for this, okay, a scientific calculator, it will be better if you buy a scientific calculator for calculations, okay, and you will be allowed to use this calculator even in the exams, okay. So the best way is to buy a scientific calculator and it will be helpful for you in the future also, if you go for higher studies. So first we have to find separately, not together, the value of square. So what we are going to do is we're going to use square. I hope it is visible. Square root 0.341 is equal to 0.58. 39. Now for 10 to the power 12 separately, square 10. So for power we use this one, power 12 equal to 1 2 3 4 5 6 60. So we'll write 10 to the power 6. And this one, square cancel, square and square cancel, so meter per second. So since this is 0, we'll 810, so it will become 5.8. We can write 4 also, since 9 here greater than 5, and if we add 1 here, then it will become 4 to the power. So 1 0 added, so it will become 5 meter per second. So therefore velocity of the photoelectron is 5.84 into 10 to the power 5 meter per second. So this is how you will do the calculations. So I ask all of you to practice these numerical problems, since one questions from this unit is most likely to come in the exam. I can assure 90% chances of coming.